The ellipse E has equation x squared plus 4y squared equals to 4, and we have to find the focus f1 and f2 of the ellipse E. E is the name of the ellipse, not a point. Now the first is we have to make the form of the equation in the standard form of the equation of an ellipse, which is x squared by a squared plus y squared by b squared equals to 1. So here it would be a squared is 4 and b squared is 1, which is 1 squared equals to, so it will be 1. That is the format of the standard format of an ellipse. Now in order to find the focus, we know the formula for the focus. The formula of the focus is plus minus AE. So if a squared is 4, then a has to be 2. Now E is the centricity, and we find the centricity using the formula, which is b squared equals to a squared 1 minus e squared. Now from here we can calculate and find the value of the eccentricity, and it is 3 by 4. If we do the square root, it will be square root of 3 by 4, and simplifying that would turn out to be square root of 3 by 2. Now we know by that formula, so we will get f1, the first of the focus, it would be negative. So a is 2 and eccentricity is root 3 by 2, so it turns out to be minus root 3, and similarly the other one would be plus root 3. It's on the x-axis, so it will be x coordinate comma 0. Now next is the directrix. So the formula for the directrix is plus minus a divided by eccentricity. So it's very simple. We know the value of a is 2 and the eccentricity is root 3 by 2, and we have one positive value and negative value, and these are vertical lines. X equals to any constant is basically a vertical line, so these two would be the eccentricity, and there is a diagram over here that shows this the directrix, which are the two vertical lines, and the focus f1 and f2. So we now have to find the distance of any point, any arbitrary point on the ellipse E, and from that point the distance of the focus from that point, there are two focus f1 and f2, so pf1 and pf2, and we have to show that the total distance is 4. Now it really helps to see what the picture looks like, and we can see that the focus f1 focus is minus root 3, f2 focus is plus root 3, and the point P is, we can put the point P anywhere, and we know that the two directrix, one is n1, there are 2 points on the directrix, n1 and n2. We can just use this because of the rule of eccentricity. Eccentricity is from any arbitrary point P, if we take the distance of that point to the focus and divide it of the perpendicular distance from that point P to the directrix. So here what we have done, we have taken the point n1, the perpendicular distance from the point P to n1, and we have taken that as Pn, and we have taken upstairs as Pf1. So this is going to be eccentricity. So that turns out to be, if we do a simple rearrangement of the fraction, Pf1 equals to eccentricity times Pn1. Now the same thing can be done with the other point Pf2 and the base of the perpendicular from the point P to the other directrix, which is n2, and we will get the same thing. Now we have to find the total of Pf1 and Pf2. If we add it up and if we take the E common, it turns out to be Pn1 plus Pn2. Now if you take a look over here, Pn1 and Pn2 is basically a straight line from the two directrix n1 and 2, and we know from the origin the length of the directrix is 4 root 3, and the other side it is 4 root 3 in terms of length. If we add the two up, it turns out to be, if we just add it up, 4 by root 3 plus 4 by root 3, so n1 n2, that is the same as the length of Pn1 and Pn2 individually, and then we multiply it with E, the eccentricity, and it turns out to be 4. This question number C, is mainly about algebra. We have a line and the name of the line is L, and we have an ellipse, name of the ellipse is E, capital E. So this line and this ellipse intersects at 2 points, and the x coordinates of the 2 points are x1 and x2, and it's a horizontal line. The y coordinates are going to be the same. Now we also know that the gradient of the line is m, So we know that y equals mx plus c is the general form of a line, and so using that we can now start solving simultaneous equation, and then we'll get a quadratic equation. And if we solve the quadratic equation, we will find two roots, x1 and x2, some rather big root. Now these are the 2 points where the line L intersects the ellipse at the 2 points. Now if we join any 2 point on an ellipse, that line is called a chord. Now for making our calculation simpler, they have mentioned about using a midpoint. So if we add up x1 and x2, we will find the midpoint. So by adding x1 and x2, what we get, we can cancel the two root portion, plus and minus. If we add it up, these two cancels off, and if we add these two up, it's basically this and this. Since they have both negative numbers, adding it would be just putting the two negative in front, and that's adding it. And we have to take divided by 2, because the midpoint rule is x1 by x2 divided by 2. So we will get the x coordinate of the midpoint, and since it's a horizontal line, the y coordinates are going to be the same. So from here we find the x coordinate, and what we really want to do is find the equation of the line. Now we know the equation of the line is y equals to mx plus c. The answer would be in terms of m, but we have to get rid of c. But the value we just found, the midpoint, x coordinate of the midpoint, we can use that as an algebra to find an expression for c in terms of m and x. So what we do, we go to the original equation y equals mx plus c, and we plug in c, and now if we simplify it, eventually we get rid of c and we find the equation of a line where we have m as the only unknown constant.